Were humans designed to eat only fruit? Were humans designed to eat only meat? Or were we designed somewhere in between, right? I'm Samir, and I'm a health coach and anthropologist based in Johannesburg. I have a special announcement. My new book, The Health Dialectic, is going to be coming out later this month in October of 2021. Click the link below to sign up and get a copy. Also, don't forget to hit the like button and subscribe to the channel. It really does help me out. So I recently reviewed the movie What the Health. In the review, I focused on arguments that the movie makes around health. I also mentioned that the movie tries to do way too much, right? One of the things that it tries to do, and it fails to do in my opinion, is to present an argument that humans evolved to eat exclusively fruit. And there's an animation, and here's a little snapshot from it, a little screenshot from it. There's an animation that talks about carnivores versus frugivores. Actually talks about omnivores versus frugivores, and argues that humans were meant to be frugivores. Now, for me, when I saw that as an anthropologist and as someone who's been studying human evolution for a long, long time, I mean, this was just prima facie silly. It was so silly that I didn't even think to mention it because I thought no one was going to take it seriously. But much to my shock and horror, in engaging with various online groups, I realized that there are many people who do take it seriously. So let's go through this piece by piece, step by step. First of all, why is it important? Why is it an important question to ask whether, how humans evolved? What does human evolution have to do with what we eat today? Well, assumably the makers of the film, who are promoting veganism, right? You can go and check out my review of that film to learn more about it. But they believe, as I do, that humans will do well on the diets that we evolved to eat, right? So we won't do well eating the foods that we're not genetically designed to eat, right? So I think everyone would agree we're not going to do well on lots of sugar, for example, because we didn't have access to lots of sugar even a couple of hundred years ago, right? So that's a shared starting point between the frugivores and those of us interested in the implications of human evolution for human health. And it's good to have a shared starting point, right? So I'm going to disagree with them a whole lot, but I just want to point out the starting point is the same. We're trying to understand human evolution so that we can, help humans be happier and healthier and stronger, right? That's our shared starting point. All right, so let's break this down piece by piece. The first thing I want to ask here is, what is a frugivore? Well, until the 20th century, so until about 100 years ago, we thought that there were animals that were exclusively fruitarians, frugivores, whatever you want to call them, right? So these were often monkeys, sometimes great apes. We thought that they ate only fruit. And then something interesting happened. So about 100 years ago, this was in the 1920s, Stephen Gundry has written about this. For those interested, you can check out, I believe it's his first book where he tells the story. There was an experience in the National Zoo in Washington, D.C. They brought in some marmoset monkeys from South America. Now, when you look at these monkeys in the wild, all they do is eat fruits. They spend their whole day picking fruits out of trees, different fruits at different seasons, and they eat the fruits. So, they brought them to the zoo. They gave them the fruits that were available at that time, apples, bananas, oranges, etc. The monkeys got very sick. Someone had the bright idea to sort of go and look at the fruits that the monkeys were eating in the wild, and he noticed that those fruits were full of worms, right? And often when you look at chimpanzees, for example, they'll take a bite of a fruit and then they'll look at it, and if it doesn't have the worms in it, the insects in it, they'll throw it away, right? So using that evidence, they introduced animal protein into the diet of the monkeys. When they did, the monkeys got a lot better. The monkeys started reproducing and so on. Since that time, it's known by pretty much any zookeepers, you can Google this, that all monkeys, even fruitarian monkeys, need a certain percentage of animal protein. And so things like worm meal are sold, or ant eggs, other insect-based foods. These have been developed specifically to keep the so-called frugivores in the zoos happy. Now, they only need a little bit, but without the little bit, they get very, very sick. Calorie-wise, it ends up being significant. So when you measure it up, you find that most so-called frugivores, and actually this is the case for many animals that we would consider to be pure herbivores, they get between 6 and 10, sometimes as much as 15% of their calories from animal protein. Sometimes it's not just insects, right? So chimpanzees have been observed to hunt and eat smaller monkeys, for example. And pretty much every so-called vegan animal has been observed to hunt other animals when needed. This is everything from the giant tortoise. There's been a video of a giant tortoise hunting a baby bird that's gone around the internet recently. Deer chasing rabbits and so on, eating rabbits. These are known behaviors, right? So as far as we know, there's no such thing as a frugivore in the sense that What the Health describes frugivores as being 100% vegan. That just doesn't exist in nature. Okay, so the What the Health line is wrong. We can dismiss that completely. I honestly can't believe anyone took that seriously. So the question then becomes, okay, were humans primarily vegetarian or primarily carnivorous, right? And just looking at that question, it's a hard question to answer for a variety of reasons. We know just by looking at current human populations around the world that humans can thrive. Humans can do very well eating either a huge percentage of our calories from meat, and we can also do pretty well eating a huge percentage of our calories from plants, right? So generally speaking, okay, so now we're talking about modern human populations. We're not talking about human evolution. But generally speaking, the closer a human population is to the equator, the more calories they will get from fruits and from vegetables and so on. So the traditional human populations who live in Arctic or even temperate zones, they tend to get most of their energy from animals. And in the tropical zones, it varies. Maybe some populations get more from plants. Some populations, of course, will get a lot from fish as well. Let me caveat this by saying that on a given day, say a population from Papua New Guinea, a PNG islander, which has been studied a lot, that's why I mentioned that population. On a given day, that person may have gotten more of their energy from animal foods. And on a given day, the European Neanderthal, which until recently was thought to be like 100% carnivorous, but on a given day, we now know that Neanderthal may have gotten more energy from plants, just because of the availability of certain foods and the unavailability of other foods, right? This is just what it means to be an omnivore, right? To have that adaptability. So that said, there are at least two sources we can use from the fossil record to learn about early human diets. The first is just the concrete evidence from the fossils themselves, right? So here is a paper talking about how Homo erectus was widely associated with elephants. So in other words, we have archaeological evidence that where the remains of Homo erectus are found, we find elephant bones, a lot of elephant bones. And we find hunting tools that we assume were used to hunt for elephants. Of course, by elephants, I'm not just talking about elephants. I'm talking about mastodons, mammoths, prehistoric relatives of the elephant, right? This is very well documented and very well understood. There are other papers that show similar patterns with other pre-human hominin fossils. So here is another paper documenting interaction between Neanderthals and prehistoric elephants in what is today Italy, right? So that's 171,000 years ago, right? There are many more papers I could cite. Almost wherever ancient human or pre-human hominin fossils are found, you find the bones of large animals, and you find those bones butchered, right? You find evidence that they've been sort of cut a certain way with a knife and so on. Interestingly, that's even the case of an elephant bone found in Southern California dated to 130,000 years ago. So, and that particular find is changing our understanding of how humans first migrated to the Americas. So the fossil record itself is pretty clear in my opinion. Humans and pre-human hominins were hunting meat, and they treasured hunting and meat enough that many people were buried with their hunting spears, right? So that includes this woman from the Andes region whose bones have been dated to 9,000 years ago, right? So it's a woman. This is shattering the myth that it was only men doing the hunting. No, we know women also hunted, right? If we want more evidence that humans were hunting, we can actually look at our own physiology. And the first place to do that is with stomach acid. So we can measure, different animals have different pH in their stomach. Of course, all animals have to have some acidic content in their stomach to break down food, right? So herbivores tend to have a pH of 4 to 5. So remember, in the pH scale, 7 is neutral. And as we go down, we get more acidic. If we go up, 8, 9, 10, then we're getting more basic. Remember also with the pH scale that every number represents a 10-fold increase, right? So 4 is 10 times more acidic than 5. 3 is 100 times more acidic than 5. Make sense? So, as I said, herbivores have a pH of 4 to 5. Carnivores have a pH of 2 to 3, so that's 100 times more acidic than the herbivores. True omnivores, so like bears, for example, they have a pH between the carnivores and the herbivores. So maybe 3 or 4, right? Humans tend to have a pH of 1, right? So that's even more acidic than known carnivores, 10 times more acidic than most carnivores, and 100 times more acidic than some carnivores, right? The only other creatures who have this much acidity in their stomach are scavengers, right? So animals that pick leftover bones and that sort of thing. So things like buzzards, hyenas, maybe jackals. From this, we can draw at least a hypothesis that humans are creatures designed to scavenge. Of course, we don't call it scavenging. We call it, dry aging meats and maybe smoking our meats and so on. But the fact is that we're eating meat 10 days, 20 days, longer sometimes, after it's been killed, after the animal's been killed. And so we're one of the few animals that does that. We do that even today. And the evidence that we're seeing from the fossil records that we used to do similar things 100,000 years ago, 200,000 years ago. So that's one line of physiological evidence. It's not the only one. There's been an assumption since the early days of anthropology that humans are unique in the animal kingdom. One of the things that makes us unique is the size of our brain. Now, this brain size science has a terrible and racist history with people sort of measuring people's skulls to tell different things about different races and so on. That's all nonsense. Please don't confuse anything that I'm saying as having anything to do with that. But it is true that at some point in human evolution, our ancestors' brains did get bigger, right? This happened at the same time, interestingly, as our guts got smaller. So the brain's a very expensive organ, and human brains are particularly expensive. What do I mean by expensive? They consume a lot of energy. So one would assume that as the brain gets bigger, you can see this in elephants, for example, as the brains got bigger, their guts had to get bigger. The whole body had to get bigger to accommodate the bigger brain. But in humans, something strange happened. In humans, the brain got bigger, but the gut got smaller. So as we can see from this chart, there's a certain point in our evolution when something changes that allows our brains to start growing at a much faster pace. And it occurs simultaneously with the shrinking of our gut. So this is a recreation of our ancestor Australopithecus, next to another of our ancestors, Homo erectus. Homo erectus, by the way, is probably our most successful ancestor in that they were around for a long, long time, longer than humans have been around for sure. Anyway, that's a massive change in our gut size, right? And this paper here shows what we would expect in terms of organ size for a non-human primate in terms of organ sizes. So in other words, if there was a gorilla or whatever that is the same size as a human, this is how big its brain would be, this is how big its gut would be. For some reasons, humans were able to escape these ratios and grow much larger brains and much smaller guts than we would expect from looking at chimpanzees and other primates. Now, there are two possible hypotheses that are currently discussed. The first is that it's possible humans started cooking much earlier than we currently have evidence for. So the theory is you're no longer processing food inside your gut, you're processing it or doing some of the processing at least outside the gut, and that's cooking, right? Now, the problem is, in order for that to make sense with this theory, that would have had to happen at least 2 million, maybe 2.5 million years ago. And the earliest evidence of fire we have is only 1 million years ago, right? So it's possible, but at the moment we don't really have strong evidence for it. Another possibility that in my view is the more likely possibility is that early hominins were using stones to scavenge bits of meat that predators couldn't access, right? So, if you look at even how lions and cheetahs and these kind of animals eat today, they kill the animal, they eat all the soft organs, the soft tissue, but there's certain things that it just cannot access, like the bone marrow, like the brains, the skull, and so on. So the theory would be that these early hominins, our ancestors, used stones to pound at these bits of bone to unleash the fat inside the marrow, the brain, and so on. These would have been highly nutrient-dense foods, and their availability could have put some pressure towards growing larger brains to find more foods like that. So in other words, what I'm saying is maybe just by chance, one of our ancestors came across this, and it was such a powerful food source that there was evolutionary pressure to go in that direction. And it was found that what was needed to get more of that food was a bigger brain. That's what I'm suggesting. By the way, these would have also been fairly easy to digest foods. So it could explain why our guts started shrinking at the same time. We didn't need that much space to get a lot of energy, a lot of nutrients. Listen, I won't go further into the details of the expensive tissue hypothesis. It's extremely fascinating. Some vegans, of course, will point out that, look, it's just a hypothesis. Which is true, but the problem I have is, okay, you have to counter that hypothesis with another more plausible hypothesis of your own. And to be honest, the hypotheses that are currently circulating, that are being promoted by certain vegan anthropologists or people who are sympathetic to that view, they're not very plausible at all, in my opinion, right? So there's some interesting data on how hominins evolved certain enzymes, so the amylase enzyme specifically, which is used to break down wheat and barley and so on. So someone has pointed out that this enzyme has developed earlier than we thought. That's interesting. So it may mean that maybe during times of famine, we were eating grains, we were eating more seeds and nuts. That's possible, but that doesn't. If that's true, that doesn't negate the bigger trend towards increasing the amount of meat consumption, right? There's also Neanderthal feces fossilized, or early hominin feces fossilized, that has been analyzed and found to have a lot of plant matter in it. Okay, that doesn't really prove anything except, what a particular human or Neanderthal ate on a particular day. Like, I think we have to examine some of this evidence and say, okay, that could be true. I don't know. But if it's true, it doesn't necessarily disprove the bigger picture theory, which is that the introduction of animal foods, and especially fatty animal foods, so not little insects and so on, but the fat from big animals, that was a driving force in human evolution. That's the hypothesis that I'm advocating, or at least I listen. I don't want to say that this is proven, but based on the balance of where we are right now, this is what I think is probably the case. And there's more evidence that I haven't really gone into, and that evidence is in some ways the most conclusive, right? So just like we can use carbon dating to, so we find sort of radioactive isotopes in carbon to tell how many million years ago something happened, right? How many million years old a particular fossil is. We can also measure radioactive isotopes in nitrogen to find out the trophic level of a given animal. This diagram explains what a trophic level is. I think we all know this as the food chain, right? So the plants eat the dead, eat everything, right? So something dies, it becomes soil. The plants sort of eat the soil, if you want to think of it that way. The herbivores eat the plants, the carnivores eat the herbivores, and so on. And from this, from measuring the nitrogen levels in the bones of those animals, we can tell where were they on the trophic level, right? So were they a carnivore? Were they a herbivore? So in this paper, researchers use the term hypercarnivore to describe our ancestors, and it notes that according to the fossil record, plants only became a significant part of our diets around 10,000 years ago, right? When we have the shifts to agriculture and so on, the so-called Neolithic Revolution, right? So in other words, what that's saying is that humans were at the top. They were apex predators, if you want to think about it that way. They were eating also some carnivores, right? So the researchers there hypothesized that they were eating fish. Fish, of course, would be eating other smaller fish. So we eat the big fish, means that we are eating carnivores, right? Again, this isn't conclusive. And there's some researchers who are arguing that the isotope measurements are slightly wonky, especially if the meat was aged or dried in a certain way. That's possible. These are debates that are ongoing. But listen, given this nitrogen analysis, it's pretty much impossible that less than, say, 60% of early hominin diets was meat focused, and it could be as much as 90% of calories, right? So, and what are the dates we're talking about? We're talking about between 1 million and, say, at least 100,000 years ago, maybe much closer, maybe more like 10,000 years ago, right? So given the evidence currently available, these are the conclusions that I think we can draw. Number one, all hominins, and indeed pretty much every animal we know of, ate some plants and some animals, right? There is no such thing as a purely vegetarian animal, in my opinion. There's no such thing as a purely carnivorous animal, right? But we can talk about preponderance. Was it preponderantly herbivore, preponderantly carnivorous? We can talk about that way. In terms of the ratio of plant food to animal food in our ancestors, it seems to have changed significantly about 2 million years ago. It seems as though our ancestors ate more meat and different kinds of meat than what they had been eating before. So no longer the insects, now it's big animals. And before that, maybe they were also eating maybe smaller primates, like we see chimpanzees hunting monkeys today. That's possible, but definitely from about 2 million years onwards, our ancestors are hunting big animals, right? I can talk in another video, I can talk about why that is. It has to do with the amount of fat that's found on those big animals. We seem to have evolved to need that animal fat. This does not mean, of course, so this is my third point, it doesn't mean that they stopped eating the plants altogether, right? This is where I think a lot of us want the answers to be like 100% this or 100% that. No. When we look at hunter-gatherer societies today, for example, the amount of plant food they eat on a given day depends on how much animal food they have around. If they have made a kill, they may not look for as many plants, they may not forage as many plants. On the other hand, if they made a kill during a good fruit season, for example, they may go ahead and grab some fruit as well, right? So in other words, what I'm suggesting is current human behavior, and maybe by extension early human behavior, is pretty complicated. And because we can get by with a whole number of different kinds of foods, just because we find some plant foods and some animal foods, it's difficult to draw conclusions about what the percentage of plants and animals were in the diet, right? It's not easy to make a kill today. But remember, the animals that they were hunting 100,000 years ago were much, much bigger, right? So if you kill a mammoth or a mastodon, that's a lot of food. And it takes the pressure off those early human populations to go out and forage for enough plant food to feed the village for a week or maybe longer, right? So again, this is a hypothesis. This is a story that sort of I'm constructing in my mind, no doubt about it. But I think the preponderance of evidence goes in this direction. So the last thing I want to say, and I don't want to make too big a deal about this, but I do want to say it, is that if someone is telling you that humans evolved to eat exclusively fruit, please do not listen to that person. Like, they do not know what they're talking about. There is essentially no evidence to back up that hypothesis. And we know that diets that are 100% fruit are deficient in a huge number of vitamins and minerals, right? So, I mean, B12, iron, zinc, folate, vitamin K, lysine, tryptophan, heme iron. I mean, I can make a long list of vitamin A. I mean, I can go on for hours about everything that your body needs that you're going to be deficient in if you decide to eat exclusively fruit, right? Now, that's not to say that some people who try a fruitarian diet for a certain limited period of time, they may thrive. And if they have been eating meat and other, high quality foods before that, they may thrive even for years before they begin to feel the effects. But they will feel the effects because this is not what humans have evolved to do. And we know that those diets are nutritionally deficient. So with that, I'm Samir. I'm an anthropologist and health coach. Please do check out the link below to sign up to receive my new book, The Health Dialectic. Stay healthy, and I'll see you next time.